Hello, y'all. Barely Berry Jr. back here for some quantum work. You can see here my image of an experiment I did in my modern lab called the Frank Hertz experiment that shows the quantized nature of subatomic particles. So you can see the little light bands. There's three of them, and there's a voltage that's accelerating uh, particles so that the uh, is passed on to some atoms and excites them so that they fluoresce. So basically, we're the three times that the uh, acceleration happens, it causes three excitations. So pretty interesting uh, fact of the way quantum works and how we could explore it and examine it. I talked about this experiment. This has been about a year ago now, just about when I was in the class. But I figured I would have a nice quantum related image in the background as I work out some more quantum stuff. I have my quantum exam tomorrow, quantum 2. I aim to do at least decent on it, enough to at least get a B out of the class. So we'll see how that goes. What I'm trying to work out right now is something called perm symbols. So I'll see how far or how well I'm getting on doing that. Right, so that's showing now. Hmm. I'm still not even sure exactly what role they play except to demonstrate certain transitions of the way orbitals are filled up in atoms. So one thing that helped me understand it was going through all the atoms in order, starting from hydrogen. Even though hydrogen has one proton, Z equals 1, and the configuration of hydrogen, which I don't remember how to do, is 1s1. So my understanding is 1 equals n, s means L equals 0, and the super 1 means that there's 1 electron. So, the L is 0. Um, the electron contributing to the spin, if we ignore anything else, is 1/2. Because the electron is a 1/2 spin particle, there's one free electron. So always the aspect of the configuration of the atom that has a free electron is what determines the perm symbol. And so we have our L. So big L still is 0. Big S still is 1/2. And J equals L plus S, which is 0 plus 1/2 or 1/2. And the term symbol takes the form 2 S plus 1 L and J. So this equals 2 1/2 plus 1. The L is 0, so that's S, and J is 1/2. So it becomes 2s 1/2. And that's pretty much the process. Still not clear on why, but hopefully it'll illuminate itself as we go through more particles. So helium has 2 protons. The configuration is 1s2. So this means that n equals 1, L still equals 0, but now there's 2 electrons. So big L equals 0. S, if I'm understanding it properly, so here there's just 1 electron, so it's going to be up or down. Here it has 2 electrons, and in order to occupy the same orbital, since electrons are fermions, they can't be in the same state. The one is up and one is down. So big S equals S1 plus S2, which equals 0, because negative 1/2 plus 1/2 equals 0, and J equals L plus S, or minus S, which equals 0 plus 0 equals 0. So the term symbol, the term symbol is 2s plus 1 Lj, the full J. So this equals 2, 0 plus 1 L, big L is 0, so that's still S, and J is 0. So that is S0. So they do put the 1 S0. The next atom is the lithium. Has 3 protons. The configuration is 1s2, 2s1. Before I was trying to figure out how to do the configuration, but I do remember on the exam, he just gave us the configuration, so I'll not worry about that. Again, we just take into account the one with a unpaired electron. So it looks like n equals 2, L still equals 0, and there's 1 unpaired electron. So it's looking like this again. So big L equals 0, big S equals 1/2. It seems like we always do the positive one first. J equals L plus S equals 1/2. So the term symbol is 2s plus 1, the letter for the L and J. So that's 2 1/2. Oh, no, yeah, 2 1/2 plus 1. L is 0, so that's S. J is 1/2, so that's 2 1/2. Looks like that is correct. The next element, and I plan on going to oxygen, beryllium. Z equals 4. Configuration. What if the periodic table gives the configuration? Nope. I dare say it was discovered in 1760. No, I'm looking at the wrong thing. Hold on. It was discovered in 1797. Lawrencium was discovered in 1961. Oh, this element is discovered as late as 2010. All right. So the configuration is 1s2 and 2s2. So it has no uh, unpaired electrons. So the term symbol in the S state is 1s0. It seems to be a recurring pattern. Boron is the next one. Z equals 5. The configuration is 1s2, 2s2, 2p1. And again, we take just the one that has an unpaired electron. Everything else, if it's all paired, it's going to be 1s0 for the term symbol. So doing the same process, uh, n seems to equal 2 for that level. L equals 1. Here's a 1L, and super 1 means there's 1 electron. So big L equals 1, big S equals 1/2. There's 1 electron. And here it was like this. J equals L plus S. So this is one thing I'm slightly confused about. Uh, okay, J has to be positive. That's what it is. The reason why we didn't do subtraction on a J here is because uh, all the zero and subtraction would just give you a negative. Now that we have 1 and 1/2, 1 plus 1/2 equals 3/2, and 1 minus 1/2 equals 1/2. So term symbols, the first one is 2 big S plus 1 L J equals 2 1/2 plus 1 P, and J is 3/2. And then we have 2 times 1/2 plus 1 P 1/2. So that equals 2 P 3/2 and 2 P 1/2. Let's see if I get the next one right, which is carbon. So carbon is equals 6. The configuration based upon what we have here is this. So now we don't have an unpaired electron, so I'll assume it's going to be 1p0. Let's see. Nope, it's much more complicated. All right, I did get the configuration correct, but that's easy. So, oh, I forgot about that. So this is what I'm forgetting about. Um, the L state, excuse me, the S state, L equals 0, has one line. The P has 3 lines. The D has 5, and the P has 7. So that means that uh, for this line, it is actually, if I take just the P, we have 1, 2, 3, and we have 2 unpaired electrons because it fills up the ground state first. We have L equals 0. We have S equals 1/2. And so as far as big S, we can do S1 plus S2, which is 1, or we can do S2, which is S1 minus S2, which is 0. I'm not sure about that though. So it's hard overlaying, just working with the L's and J's and so forth with the configuration and term symbol thing. I'm trying to remember how does, well, I see. Hold up. That's what I did wrong. I wrote down my L wrong. So in the habit of writing 0, and this is F, but P, L equals 1, and ML equals -1, 0, 1. That's the 3 rows, or it could be considered the 3 rows. I'm trying to figure out what's going on with this part. So this seems correct. Oh, crap. Had disappeared. So right. So this is the max S. Big L1 equals L equals 1 plus L equals 0, which equals 1. Oh, technically, so we have L that gives us our MLs, and then MLs add up to be big L. And this is where the saying they're pointing in the same direction. Right. J equals L plus minus S. I see. So we have to do big L, which is 1 plus minus plus 1 equals 2. 1 minus 1 equals 2. We are 0. And let's do the 0 option. 1 plus minus 0 equals 1. So J equals any of these. So far as I can tell, you're adding up the MLs. With the L in every possible way. Right? So the term symbols are going to be 2L, 2S plus 1L and J. So we have n is always 1. So we have 3 key 0 or 3 key 1 or 3 P2 for the ground state. And I'm not familiar with the excited state. So it's saying I'll ask about it later. 1, 2, or 1s0. And this I'll have to ask about. All right, so 2 more nitrogen, Z equals 7, and the configuration should be clear. It's this with P3, but each of those should be unpaired. So we still have N equals 2, little l equals 1, and 3 electrons. We have big L equals 1. Oh, so this is interesting. We have 3 unpaired electrons, but all of them, since we have to fill up the lower orbital first, it seems they're all going this way. They seem to go up first. Right. And this is for each of them, the little s. Right. So since all the spans are in the same direction, it's 1/2 plus 1/2 plus 1/2. So we have a big spin of 3 halves. And ML equals -1, 0, 1. So big L equals ML plus ML plus ML equals 0. I'm not sure why we don't add them in different ways like the last one. That's because they're all filled. We can't swap them around because we don't know which one is going to be which for 2. But for 3, all of them are covered. So the perm symbol is still S 1/2 plus 1. The letter for L, J, which is going to be 3/2 plus 1/2. That's 4/2. So it's going to be 2. L is P. And J equals L plus minus S equals Oh, it's just 3 over 2. All right. Uh-oh, I'm missing one. So how did I get 4 on top? Oh my gosh. I'm used to putting 1 for the what's column. That's 3 over 2 times 1 over 2 plus 1 p 3 over 2, which equals 3 over 4 plus 1 over 4. Right? Feel like I'm messing something up. That's what it is. So now 1/2 is 2s. 2s plus 1. So there's 2 3/2 plus 1. So that is 4 p 3 over 2. Okay, it adds up. And we'll do the last one. Oxygen is Z equals 8. So the configuration would have to be 1s2. And thank you all for watching. Like and subscribe if you haven't. Let me know if you have any questions before I log off in a bit. That's what I believe the configuration is. Let me check and see. Yep, that is correct. So it seems to me we still have n equals 2. Uh, little l still equals 1 because there's a p there. And there's 4 electrons now. And little s for each of them is 1/2 for each of the electrons. So what we can do now, you can say big S equal, because now we have this. So if you add them all up, you can have 2 for the max S. Nope, it says max is 1. Oh my gosh, I forgot it's 1/2. So we can have 1/2 minus 1/2. It's going to be the left one plus 1/2 plus 1/2. So S, big S equals 1. The subshell is more than half filled. Oh, so here, J equals 3 over 2 or 1 over 2. Uh, subshell half filled. I guess when it's half filled, it favors the big one. Big L still equals 1, I would say. We favor the highest J since it's more. Oh, J more than half field, big J. So the biggest J we can get is J equal 2. So the term symbol is going to be 2s plus 1 LJ, which is going to be 2 big S plus 1 is 3P. Now it says the big J is favorite, but it's not necessarily doing that. Perhaps that's what the professor said. Pick one possible J. So perhaps it's too complicated to get through all the ones, but we know 2 is a possible J. So this is one of the answers. But I have to think about how perhaps one of the other J's will work. And maybe what I'll do is come back and continue some more of these. Thanks so those who watched. She'll be back um this afternoon sometime, or if not this night. And hey, what's going on, Sabrina? Glad you enjoyed. And I'll be back later today, preparing for my quantum exam tomorrow. And if I figure out some more details about this, I'll continue it here, or I'll continue with one of the other subjects. But we will get some more, uh, when I say advanced, at least advanced for undergraduate, quantum level stuff done. So, awesome, Sabrina and everybody else. I'll see y'all later today.